The moon isn't following you. It's 384,000 kilometers away, and that distance is exactly why it seems like it does. You noticed it as a kid. Driving down the highway at night, the moon seemed to follow your car. Trees, buildings, and signs all rushed past. But the moon hung there, fixed in the window, moving with you. You weren't imagining it. But the moon wasn't moving either. This is one of the oldest optical illusions in human experience, and it reveals something fundamental about how your brain calculates distance. The answer is parallax, the apparent shift in position of an object based on your viewing angle. When you move, nearby objects shift rapidly against the background. A tree 50 meters away sweeps across your field of vision in seconds. A building 1 kilometer away moves more slowly. The moon, at 384,400 kilometers, is so far away that your movement, even at highway speeds, produces zero detectable parallax. You'd need to drive for thousands of kilometers before the moon would shift by even 1 degree against the stars. So your brain registers every nearby object as passing by, while the moon stays in exactly the same position in your visual field. But here's the deeper reason it feels like the moon is following you. Your brain uses relative motion to interpret the world. When a nearby object moves to the left in your vision, your brain assumes you're moving to the right, or the object is passing you. When everything nearby moves, but one object doesn't, your visual cortex has 2 options. It's stationary at infinite distance, or it's moving with you. Your brain defaults to the second interpretation because in everyday life, objects that match your speed are usually traveling alongside you. The moon triggers the same pattern recognition that you'd use for a car in the next lane, except the moon isn't moving at all. This effect was first described by ancient Greek astronomers. Aristarchus of Samos used parallax in the 3rd century BC to estimate the distance to the moon, one of the first measurements of any celestial object. Today, astronomers use the same principle in reverse. By measuring the parallax of nearby stars, their tiny apparent shifts as Earth orbits the Sun, they can calculate distances to stars up to about 10,000 light-years away. The Gaia spacecraft has measured the parallax of nearly 2 billion stars. The same illusion that confused you as a child is one of the most powerful distance-measuring tools in all of science. The moon isn't the only object that does this. On a long flight, distant mountains seem to hover in place while the ground below races past. Tall skyscrapers viewed from a moving car appear to rotate slowly. And the sun produces the exact same following effect. You just rarely notice because you don't stare at the sun while driving. Any object far enough away relative to your speed will appear stationary. The threshold is roughly 1,000 times your viewing distance. Anything beyond that distance effectively has zero parallax from your movement. The simplest questions often hide the deepest physics. Subscribe to Curious Science to keep asking them. What childhood observation always puzzled you? Tell us in the comments.